Welcome to Metal Casting Lecture Series by Professor Joyjeet Ghose. This is the 17th lecture of a series of lectures. This lecture will be on die casting, centrifugal casting, and continuous casting. Hot chamber die casting and cold chamber die casting will be discussed. True centrifugal casting, semi-centrifugal casting and centrifuging will be discussed. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture 17 of a series of lecture on metal casting. In this lecture we will be discussing about die casting, centrifugal casting and continuous casting process. So die casting is basically a casting process where you use die or permanent mold, and in this die we fill the die cavity with molten metal under pressure. So it is called pressure die casting actually. And it can be of two types, hot chamber die casting and cold chamber die casting. It is a extremely productive casting process and is very widely used, especially the cold chamber die casting, widely used in industry for producing aluminum or zinc components required in mass. So first we'll be discussing the hot chamber die casting. So in hot chamber die casting, basically there is a melting unit which is an integral part of the die casting unit. And this is basically a steel tank where the metal is melted, and we have this die. The die is made of two components. One is immovable, one that is fixed, other is movable. So these are essentially the toggle and all things are basically used to move. Nowadays we use hydraulic moving device where it can be, this is or pneumatic device can be used to move the dies. So the gap between these two dies are filled with the molten metal, and there are cores can also be used, and ejector pins are used to eject it. So there is a gooseneck pipe, and you can see there is an opening in the gooseneck pipe here. What happens when the plunger of a hydraulic or pneumatic device moves up? So this port opens. As this port opens, the molten metal enters into this gooseneck pipe, and as it comes down, the molten metal will be pressed into the gap between the two dies. It is kept under pressure for a few seconds of time, and then it is released and the ejector pins opens and the component is ready and is ejected from the dies, and again it is assembled. Again the plunger moves up and the port opens and fresh molten metal enters, comes down. This fresh molten metal enters into the die cavity, solidifies, then ejected. This part moves and then ejected. So in this manner it takes place. So this is since this is a permanent mold, we cannot use ferrous material because the temperature is very high, then die life will be very less. And we use non-ferrous metals basically for this process. We use lead, tin, zinc. Aluminium and copper are normally not used because we are melting it in a steel tank. The aluminium and copper may react with the steel tank. So hot chamber die casting is not suitable for aluminium and copper. For that we use cold chamber die casting. In cold chamber die casting is basically similar to that of hot chamber die casting. Only thing is that the melting unit is not a part of the casting unit. Rather we melt it in a different location and then we bring it and pour it. This is also for low temperature melting alloys and basically non-ferrous melting alloys like copper, aluminium, etc. This is a very popular, extremely popular casting method in industry, and it's very fast process. In 1 to 10 seconds you get a particular component, and thousands of components can be produced in a day, and it gives a very good surface finish. Very thin sections can be cast. The defects are also very less, and post casting operations are also very less. So here we pour it in this pipe, and there is a plunger which pushes and under pressure between the two dies, or between in the die cavity, and then it solidifies there and then ejected. This takes very less amount of time, probably around 10 seconds time. You can easily cast a component of medium size, depending on the thickness, of course. So this is die casting. Some advantage of die casting is that production rate is very high, thin sections can be cast, close dimensional tolerance can be achieved, and movable cores, fine details can be produced, less floor space is required, normally it is CNC controlled, not economical for small runs, only economical for non-ferrous alloys. Ferrous alloys cannot be cast due to high temperature of the molten metal. Die life is less, die cost is also high, and of course one problem is that air may be entrapped, so we have to be very careful while carrying out this process, and the maximum size is also limited. So this is the difference between hot chamber die casting and cold chamber die casting, very often asked in the exam. So with this we move on to centrifugal casting. Centrifugal casting can be of three types: two centrifugal casting, semi-centrifugal casting, and centrifuging. So two centrifugal casting are used for long molds, long components without any seam, and which is axisymmetrical about a horizontal axis. And we have semi-centrifugal casting and centrifuging. So two centrifugal casting can be horizontal or can be vertical. So vertical centrifugal casting, two centrifugal casting are normally used for short height component. For long components, horizontal centrifugal casting are used. So you use a metal mold here. This metal mold is lined inside with refractory coating, and it is rotated at a high speed. And when you pour in molten metal, what will happen? Under the centrifugal force, the molten metal will be thrown towards the wall of the cylindrical metallic die, and under the centrifugal pressure it will solidify. So what will happen in this process? It will give a very good casting because it will be solidified under pressure, and the dense metal will be towards the wall and the impurities will be towards the inner core, which can be easily removed by machining process. So this gives a very good casting, and it is coreless. Without cores we can produce a hollow cylindrical casting in this process, or axisymmetrical casting in this process. So this is two centrifugal casting. You can see this is the die which is, or the mold which is rotated, and we pour the molten metal. It is rotated at high speed, and centrifugal force will throw it towards the wall of the mold and where it will solidify. So the mechanical properties of centrifugal cast are better compared to other processes, and the segregation of the slags and oxides on the inside, and it can be easily separated. Good uniform metal properties, no sprue grades or to remove. Outside the casting is at required dimensions, lower material usage, no cores are required. So these are the advantages. Some advantage: the equipment cost is high, inner metal of the part contains impurities which has to be removed, only simple shapes can be made which are axisymmetrical only. So these are some of the limitations of true centrifugal casting. So this is semi-centrifugal casting. Semi-centrifugal casting is also used for components which are axisymmetrical, and you can see there is a table on which the mold is mounted, and there is a core, and this rotated table is rotated at a certain speed, and because of centrifugal casting, the material will flow to different corners of the mold. The mold is made of sand. The mold is made of sand. So here the centrifugal force is only used to distribute the molten metal to various corners of the mold cavity. So this is semi-centrifugal casting. And then there is a difference between semi-centrifugal casting. You can go through, very often asked in the exam. The rotation of the mold aids in directional solidification. The true centrifugal force pushes the molten metal into complex parts of the cavity. The impurities get solidified near the central core and it can be removed. and normally it is rotated at a very less speed, whereas this two centrifugal casting is rotated at a high speed. So it can be vertical or horizontal, but normal centrifugal casting, semi-centrifugal casting is about a vertical axis only. So you have a sand mold here, and this is a metal mold, permanent mold. Then you have centrifuging, when number of molds are created in the sand, and it is rotated at a high speed. And molten metal will be distributed to different cores by the centrifugal force. So this type of casting processes are called centrifuging, centrifugal casting. So centrifugal force is basically used to distribute the molten metal to different parts of the mold cavity. Okay, now traditional method of steel making includes ingots from molten metal. Now nowadays in steel industry, they are not making ingots and then further processing it for steel plates or sheets. Rather, the steel is produced and directly cast using continuous casting, where there is a mold which a copper mold is there, and which is water cooled copper mold is there. It is dropped at height from the tundis, and as it solidifies, there are river rollers which pinch it, and it will be steel sheets will be produced by this method. So I'm not going into details of continuous casting. It's a very complex, of course, but at this stage probably you will not require that much understanding of a continuous casting process. Only thing is that it's a casting process used in steel industry. Earlier steel industry used to make ingots and then further process the ingots to make plates, thin sheets, etc., etc. Nowadays steel is made and directly poured in a mold at a very great height, and then as it solidifies, it is rolled and the thickness is managed and then cut into pieces using oxylance cutting process. So with this we come to this end of this lecture. Thank you for watching this video.